Hey guys, this is Mr. Gordon here with the Exponential EOC practice problems that I asked you to put in your math toolkit last night. I'm going to show you how to do these now. Hope you guys are doing good this morning, feeling awake. Mr. Messi, hope you're well also. Alright, so number 11 we're starting off with. So this one you guys should have seen before. But basically we have two functions. So we have this function right here. Based on what we talked about yesterday, we should be able to identify the y-intercept of that function. Because remember, a times b to the x power, a is the y-intercept, so the y-intercept here is 2. The y-intercept of the function we're given in the graph is negative 3. So it says that function was replaced with f of x plus k. So what could I add to 2 that's going to bring it down to negative 3? I'd have to add negative 5, so the value of k is negative 5. That should be your answer for that one. Alright, we've done this one a couple times. Katie and Jennifer are playing the game. I want to compare Katie and Jen. They each started with 100 points. So that's the beginning, and I'm using the beginning because it says at the start of each turn. So at the beginning of turn 1, they each have 100 points. It says at the end of each turn, Katie's points doubled. So at the end of turn 1, her points doubled. That's the same as the beginning of turn 2, which is at 200, because 100 times 2 is 200. Jen's points increased by 200, so 100 plus 200 is 300. Then the start of the beginning of turn 3, Katie doubles, so 200 times 2 is 400, 300 plus 200 is 500, so Jen is adding 200, which leads us to the beginning of turn 4. Now Katie's at 800, Jen's at 700, so the beginning of turn 4 is when Katie first has more points than Jennifer. Alright, number 16, this is what we talked about yesterday in your math toolkit. You should turn to the back side, the last exponent rule, which is radical exponent rule. So we have x to the m divided by n equals the n root of x to the n. So in other words, the denominator becomes the root index for the number in front of the radical. So the root index becomes the denominator. So this number will become the denominator of every fraction. X to the 2/3, y to the 3/3, e to the 4/3. The 3 became the denominator in every single one of those instances. Now for the first one, that's 8 to the 1/3, which you can go ahead and type in your calculator. See that that's a 2. So I have 2x to the 2/3, y to the 3 divided by 3 is 1, e to the 4/3. So that is b. Alright, now we have a power to a power. So if you guys look in your exponential rules math toolkit, what do we do when we have a power to a power? We multiply. That's right. So what is 1/3 times negative 3, which is like negative 3 over 1? Yep, that's negative 3 over 3, which equals negative 1. So we have x to the negative 1. Now we have to look at our negative exponent rule. Negative exponents are sad. To make them happy, we move them to the denominator, where we have 1 over x. And finally, Monica did an experiment to compare, well, not finally, we have a couple more left. Sorry, my wife is distracting me by making sad faces, because I'm in the TV room blocking her from watching HGTV. Monica did an experiment to compare two methods of warming an object. The results are shown in the table below. Which statement best describes her results? So let's read through these answer choices first. The temperature using both methods changed at a constant rate. The temperature using both methods changed exponentially. Method 2 changed at a constant rate, or method 2 changed exponentially. So we need to understand what is a constant rate, or a linear function, and what is changing exponentially. So changing exponentially means it's always multiplying by some number. And constant rate means it's adding or subtracting something every time. So if I look at this, that's plus 5, then plus 6, but then plus 4. So this is not constant. So anything about both methods at a constant rate, that can't be true. But it's also not multiplying by the same number every time. So they can't both be exponential. If I look at this one though, it's clear that it's multiplying by 2 every time. So that's exponential growth all the way through. The temperature using method 2 changed exponentially. Sorry, I think my mic fell out there. So we can see the second column is multiplying by 2 every time. So that means the temperature using method 2 changed exponentially. Alright, this one is pretty challenging. As I said, with these EOC problems, there's always a trick. So it says the value of an antique car is modeled by the function b of x equals 107,000 times 1.009 to the 2/3 x, where x is the number of years since 2005. By what approximate percent rate is the value of the car increasing per year? Well, this is in our form y equals a times b to the x, almost, because it's b to the 2/3 x. So can we rewrite that somehow so it's just b to the x? How about 107,000 times 1.009 raised to the 2/3 raised to the x? That's a legal move because the power to a power rule says I would just multiply these two things, which will give me 2/3 x. So let's type this 1.009 to the 2/3 in our calculator and see what we get. So when I do that, I get 1.00599, which is basically 1.006. So if I rewrite this, b to the x equals 107,000 times 1.006 to the x power. Now I can work with this. That's 1 plus 0.006. So what is 0.006 as a percentage? We'll multiply by 100 and I get 0.60%, which is, so that's a hard one because it combines exponent rules and exponential functions. But that's what these EOC questions are always doing. They're always combining multiple concepts. And that one should be doable now that you've seen an example of how to do it. This one should be a piece of cake. Now next rule, what's happening to get from 2 to 4, and then 2 to 8, multiply by 4. 8 times 4 is 32, 32 times 4 is 128, so it's next equals now times 4, which is 8. Thank you guys for watching. Hope you have a splendid day.